Thank you for joining us today. I'm Brian Landerman, an enterprise strategist at AWS, and I'm part of a small group of former C-level executives that led large-scale migrations of our company's infrastructure to AWS. We work with customer executives as they work through their transformation journeys by sharing our perspective and experience having led our own people, process, and technology transformations. I'm joined today by Chaya Pandey, a principal product manager for AWS Lambda. Prior to joining AWS, I was the CTO at Cox Automotive, where we built and operated solutions like Autotrader.com, KBB.com, a platform that hosts 60% of automotive dealership websites in the US. And each of those solutions seeing over 20 million visitors per month. We built a CRM, ERP, a vehicle service management solution, and a credit app portal connecting consumers to lenders through dealers, among other solutions. These solutions aim to improve consumer car buying and create operational efficiencies for dealership operations. With this diversity of solutions and an engineering team of more than 2,500 across 15 locations in the US, architecting cost-effective solutions was top of mind, and a new skill we had to develop as a team. We wanted to leverage modern cloud-native technologies to create business agility and increase the speed of value delivery. To us, the best way to accomplish that was by leveraging managed services and serverless technologies like AWS Lambda. But for Lambda, being a pay-for-value service, it was challenging to predict costs. During late 2019 and early 2020, AWS Lambda launched two major offerings that affect Lambda pricing. Let's take a look at how those changes affect customers using or planning to use AWS Lambda. We'll start with an overview of the modern digital business and how to think about technical cost and the total cost of ownership. Modernization is a top priority for businesses. IDC predicts that in the next few years, over 50% of information communication technology spend will be for digital transformation. And 90% of companies are engaging in some form of digitization, while 67% of business leaders believe they need to have significantly more digital capability in order to remain competitive, according to McKinsey and Gartner, respectively. So when organizations think about modernization, they typically address 5 areas. Becoming customer obsessed by creating frictionless and immersive experiences, by working backwards from the customer problem, and organizing for value by aligning leadership, funding, incentives, and organizational structure to drive discrete business outcomes. And testing and learning using focused experimentation by creating and testing hypotheses to create a learning culture and drive investment and prioritization based on that learning. And treating technology as a core business enabler. Tech-savvy leaders use technology to solve business and customer problems, not just to achieve cost efficiencies. And by strategically using data, we can improve decision-making and strengthen products and services by sharing data and making it easily accessible to the organization. But today, we're going to focus on the value and technology characteristics of a modern digital business. When we think about modern applications, they really take a different approach across 5 familiar technology vectors: architectural patterns, the operational model, software delivery, management and governance, and data management. Modern applications are composed of modular components that leverage managed services to reduce the operational load. Now, these components are owned by teams that own all aspects of the product or service, making security, compliance, and governance practices everyone's responsibility, not just, for example, the responsibility of the security team. And they leverage purpose-built databases to simplify solutions and data management. Perhaps most importantly, these components are built, deployed, and tested in a standard and automated fashion to create consistency and increase the frequency and safety of deployments. Applications built in this way enable you to achieve the agility you need to innovate on behalf of your customers. And serverless technology is the best way to maximize agility because with serverless, AWS takes on more of the operational load. So before we proceed, I just want to clarify a bit more about what we mean by serverless. Serverless technologies are building blocks that eliminate the need to manage servers, patch them, or scale them. These building blocks are highly available and automatically scale based on real-time demand. And it is based on a pay-for-value pricing because you're explicitly paying for the execution of your business functionality, not for your server to sit around and wait for demand. This strategy, often referred to as a serverless operational model, enables you to dramatically reduce the time spent on things that aren't core to your business, allowing you to focus on the products and services that drive your business and solve your customers' problems. Many customers have made a decision to achieve this value through a serverless strategy called serverless first, or by making a decision to use serverless services as a preference, unless, of course, the use case or workload demands that they choose otherwise. Customers like iRobot, Alma Media, and Fender have switched to serverless first. With this type of low-cost, value-based pricing, it can be very easy and cost-effective to experiment and explore. But as you adopt serverless for more intensive workloads, you need to recalibrate your cost planning and architectural decisions. So when we think about total cost of ownership, or TCO, we have to look at the complete picture. With cloud computing, we have greater visibility into costs and can more easily tie those costs to specific products or applications. So when we look at TCO, we must consider infrastructure costs, maintenance costs, and development costs. Not only do we need to look at hardware, bandwidth, power, and licensing, but we also need to think about the investment of time to build and maintain it ourselves. Acquiring, provisioning, patching, and operating servers comes at a cost, and the longer it takes to deploy changes and derive value is perhaps the greatest cost of your solution. To dive into these concepts more deeply, I'm going to turn it over to Chaya Pandey from the AWS Lambda team to talk about TCO for Lambda and serverless applications in more detail. Chaya?
Thanks a lot, Brian. Hello, everyone. My name is Chaya Pandey, and I'm a PM on the AWS Lambda team. As Brian mentioned, infrastructure, dev cost, and maintenance cost are the three pillars of total cost of operation estimation for any enterprise looking to go serverless. For infrastructure costs specifically, serverless offers more efficient use of compute and storage capacity, optimization of licensing costs, and reduced operating costs. This allows customers to reduce costs associated with deploying and running their IT infrastructures. Improved agility in building, delivering, and modifying applications pays off for the effort to rewrite applications using the serverless architectural paradigm. Lower costs gained from fully managed infrastructure and functions as a service efficiencies that virtually eliminate compute waste are drawing startups to exclusively build applications with the serverless model. Here is how one of our customers moving from another cloud solution to AWS Serverless had to say about their infrastructure cost savings. A rough estimate based on a customer survey values these cost savings at $2.24 million per enterprise, or $80,000 per application per year. The next big piece of your serverless savings is maintenance costs. Time to access compute and storage resources is a useful proxy for IT agility. This slide shows how, according to an IDC study, AWS Serverless Platform customers have reduced the time required to access compute and storage resources to minutes, with on-premises migrators seeing reductions from hours or even days, and migrators from other cloud solutions seeing substantial relative reductions. With typical deployments measured in minutes, study participants have made significant strides in minimizing the extent to which extending and making changes to their IT environments exert a drag on their business operation. For example, one organization reduced the time needed to deploy new compute resources from 10 days 1 hour by moving from on-premises to AWS Lambda and the AWS Serverless platform. On an average organizational basis, study participants reported cutting the time required to deploy new compute by an average of 89% and new storage 96%. Here's how one of our customers is thinking about their maintenance costs. They have a multi-region deployment, and if they release a new image version on average twice a month across 6 stage/region pairs, it takes them 12 developer hours of effort at roughly $70 per developer hour. That's $840 per month on host maintenance for this deployment in a server-based architecture. And they have hundreds of similar processes. Using Lambda should reduce their operational burden by at least $840 per month for this one deployment. This is the right way to think about the savings in dev costs for a serverless technology. The third and the most important pillar of serverless TCO is savings in dev costs. Customers tell us how their development teams have captured significant productivity gains because they need less time to deliver an increased number of new applications and features. This also fosters innovation. Let's take a look at dev cost savings data from our customers. Overall, their development teams can now develop and release more new applications and features as compared to their business counterparts, even as they speed up development life cycles to a substantial extent, 76% and 66% faster for new applications and features, respectively. For example, an on-premise migrator cut its development lifecycle for net new applications from 6 months to 1 month with the AWS Serverless platform, and an organization that moved from a mixed environment reported quintupling the number of new features it delivers to the business per year. This means that development teams generate and deliver more value to their businesses. The average productivity increase for the development teams is reported at 33%. Development teams capture significant productivity gains because they need less time to deliver an increased number of new applications and features. Further, teams responsible for IT infrastructure and application management require less time for day-to-day monitoring, deployment, and support. IDC puts the annual value of efficiencies and productivity gains at an average of $4.64 million per organization, or $165,000 per application. Organizations increase the velocity with which they can address business opportunities, which results in higher revenue. Further, end users benefit from faster delivery of new application and features. The value of revenue and productivity gains is quantified at an average of $3.21 million per enterprise, or $114,000 per application per year. With these 3 pillars to think about serverless TCO under our belt, let's next dive deep into Lambda pricing. So Lambda was launched a little more than 5 years ago, and we had 2 pricing dimensions: requests and duration. You are charged based on the number of requests for your functions and the duration, the time it takes for your code to execute. Lambda counts a request each time it starts executing in response to an event notification or invoke call, including test invokes from the console. Duration is calculated from the time your code begins executing until it returns or otherwise terminates, rounded up to the nearest 100 milliseconds. The price depends on the amount of memory you allocate to your function. The AWS Lambda resource model, you choose the amount of memory you want for your function and are allocated proportional CPU power and other resources. An increased memory size triggers an equivalent increase in CPU available to your function. Later last year, we launched Vision Concurrency for Lambda. While customers loved the ease of use that came with Lambda, they wanted to run an even wider range of applications on Lambda, applications that had strict latency requirements and that needed to support high velocity traffic bursts. Provision concurrency primarily addresses two concerns for AWS Lambda customers. First, it enables fast scaling by allowing customers to scale up to the entire provisioned amount at once, going around Lambda's default burst limit of 3,000 concurrent. Second, it eliminates cold starts by pre-initializing sandboxes to support applications that have strict latency requirements. The ability to use on-demand Lambda instances when we exceed the provision concurrency is optional. You can also configure Lambda to throttle requests above the provision concurrency. In this example, traffic spike exceeded the pre-provision concurrency and Lambda started additional sandboxes using its default behavior. This caused a P100 traffic spike for the cold start of the new instances. This chart shows how we would manage our provision concurrency hitting just the right times. Through the integration with application autoscaling, you can schedule the concurrency provisioning. Provision concurrency is configured in increments of 5 minutes. If the traffic exceeds the provision concurrency, it is handled by on-demand Lambda and adheres the default Lambda limits and behavior. Now let's talk about provision concurrency pricing. Provision concurrency charges across two dimensions: the duration of the provision concurrency period in increments of 5 minutes and the function execution duration, just like regular Lambda, but at a lower price. Earlier this year, we launched Savings Plan for Lambda, which is an easy-to-use, flexible discount mechanism to get discounts for committed usage on Lambda, EC2, and Fargate. Let's look at Savings Plan. What are Savings Plan? They are a new pricing model that offer deep discounts on EC2, Fargate, and Lambda usage. You can sign up for a savings plan by committing to a consistent amount of usage, such as $10 per hour, for a 1 or 3-year term. Savings plans offer the exact same discounts as RIs, but with greater flexibility. These discounts apply across EC2, Fargate, and Lambda usage, even as the compute requirements change. So you might choose to start with EC2 and then decide to switch your applications to Lambda, but your commitment to AWS compute would still apply to your Lambda usage and you will be discounted on it. When customers sign up for Savings Plan, they will be charged discounted prices on their usage up to the hourly commitment. Any usage beyond the hourly commitment will be charged at regular on-demand rates. AWS offers two types of savings plans: EC2 Instant Savings Plan and Compute Savings Plan. EC2 Instant Savings Plans provide the deepest discount in exchange for a commitment to usage of individual instance families in a region. For example, commit to a consistent level of M5 usage in North Virginia. Compute Savings Plan provide the most flexibility and help reduce usage costs by up to 66%. These plans automatically apply to EC2 instance usage regardless of instance family, size, AZ, region, operating system, or tenancy, as well as Fargate and Lambda usage. For example, with Compute Savings Plan, you can switch from C4 to M5 instances, shift a workload from IAD to EU, or move a workload from EC2 to Lambda at any time and automatically continue to receive discounts. AWS offers the broadest and deepest selection of compute instances and compute services, including 200 instances in 22 regions around the world and services such as Fargate and Lambda. While customers love the deep discounts offered by RIs, they have asked for an easier way to save money. Customers asked for a flexible pricing model that can apply across a broad selection of compute options offered by AWS. They wanted a model that will continue to offer discounts even as their compute needs change to keep up with their ever-changing dynamic environment without incurring any additional management overhead. Continuing on this journey to continuously improve and offer innovative pricing options, we introduced Savings Plan, a new flexible pricing model that is designed from the ground up to address our customers' feedback. Savings Plan is the easiest way to save on compute. Customers can sign up for Savings Plan in a few simple steps using the AWS Cost Explorer. If you would like to make a capacity reservation on EC2, you can reserve with on-demand capacity reservations. If you have active savings plans, your capacity reservations will be charged at savings plan rates. Let's take a moment to recap Savings Plan. Savings Plan is a new pricing model that will provide the exact same discounts as EC2 RIs in exchange for a commitment for 1 or 3 years. We offer two types of savings plan. First one is compute savings plan that is applicable across EC2, Fargate, and Lambda. Compute savings plans offer discounts regardless of region, instance, family size, tenancy, and operating system. The second type of savings plan is EC2 instance savings plan that is applicable on a single EC2 instance family. With this overview of savings plan, let's take a deeper look at how it would apply to a typical customer's bill. So in the example here, this customer has EC2, Fargate, and Lambda usage for this hour in question, and they have made a commitment of $100 per hour. So when we sum up their usage by services, we see that all of their EC2, Fargate, and Lambda compute usage falls under their commitment level, and hence it'll be discounted. Now let's look at this customer. They have usage across EC2, Fargate, and Lambda as well, but some of their request usage does qualify for savings plan. So at 20 cents per million, this customer had 25 million requests for the hour, of which $1 worth of requests, which is 5 million requests, will be covered under savings plan, while the remaining 20 million will be covered under regular rates. So any usage that overflows the level of commitment a customer has made would apply to on-demand. These are the levers that you have at your disposal to optimize your Lambda pricing depending on your use case. So you can pick from on-demand Lambda, provision concurrency, coupled with compute savings plan to optimize your Lambda bill, and then evaluate that using the TCO framework that we had talked about earlier with the three pillars of infra cost, dev cost, and maintenance costs. With that, I would like to invite Brian back to recap the TCO infrastructure framework that we had talked about.
Thank you, Chaya. That was a great deep dive into Lambda's pricing and savings plans. Now, remember, as we discussed, we must consider all CapEx and OpEx costs when looking at TCO, including infrastructure, maintenance, and developer costs. And when we do that, it's really quite simple. By combining infrastructure and maintenance cost savings, let's say for a typical application running only on weekdays, if you save just 10 minutes per month in operational overhead, serverless will beat out server-based architectures on TCO. We've already seen that the actual savings in maintenance costs are between 88 and 96% lower, which obviously results in much more than 10 minutes of savings. And when IDC interviewed 11 AWS customers, they estimated that organizations will achieve an annual average benefit of $382,600 per business application, or $10.71 million per organization on AWS serverless when compared to on-premises or applications hosted on server-based architecture. We'd encourage you to use this framework for evaluating how AWS serverless can positively impact your TCO. Thank you all for joining us today. If you have any questions about any of the topics we've covered, we're happy to answer them now.